Hello, my name is Haley Cooper, and I am giving a presentation today on the murder of Michella Welch. Here is an overview of the case. On March 26, 1986, 12-year-old Michella Welch went with her two younger sisters to spend the afternoon in a park in Tacoma, Washington. Michella left the park briefly to return home to make lunch for she and her sisters. Upon returning to the park, she was unable to immediately locate her sisters, so she started looking around. Unbeknownst to her, her sisters had left the park to go use the restroom at a nearby business. Michella was last seen by witnesses searching for her sisters. When her sisters returned to the park a little while later, they could not locate Michella, and the police were eventually called to search for her. Responding officers searched but were unable to locate Michella. A more extensive search was then conducted by search and rescue into the evening hours. Search dogs located Michella in a gulch approximately a quarter of a mile away from where she was last seen. An initial inspection of Michella's body revealed a sexual assault likely occurred. Her upper body was clothed, but her shirt had been raised just above her rib cage. She was not clothed from the waist down. Her pants and underwear had been pulled down and left around her right ankle. Michella's case would go cold for over 3 decades before advancements in DNA technology could bring a resolution to her case. The forensic evidence used to solve Michella's murder was confirmatory testing and DNA typing. Later in the investigation, investigators used DNA phenotyping and forensic genealogy. The methods of collection are uniform across all of the forensic evidence used in this case. After discovery of a crime scene, a dead body is either processed, one, directly at the scene by a forensics team for collection and preservation of evidence, or the body is transported to the medical examiner's office for processing. During the collection of evidence, all precautions against contamination must be taken. This includes wearing protective clothing to minimize the loss of hair or dandruff or other biological material from the persons collecting the evidence, wearing gloves and changing them every time the new evidence is to be collected, using tools such as tweezers to collect the evidence. It is also imperative that positive and negative controls are collected, as well as elimination samples. Elimination samples are known samples of DNA collected from all personnel at the scene who could possibly have contributed to the DNA. Any types of biological evidence, such as wet blood or bodily fluids, are never to be packaged in airtight containers because moisture can build up and that promotes the growth of bacteria that can degrade DNA. Paper bags alternately should be used or breathable containers. In Michella's case, her body was transported to the medical examiner's office for an autopsy. The cause of death was determined to be blunt force trauma to the head. She had a 3-inch depressed skull fracture on the right side of her head near the temple and a 7-inch laceration to her neck. There was evidence of both vaginal and anal trauma confirming a sexual assault. Oral, vaginal, and anal swabs were collected, as well as swabbing from the right thigh. Now moving on to methods of analyzing. For confirmatory testing, it is conducted to confirm the presence of sperm or seminal fluids. The only unambiguous test for seminal fluids is the identification of sperm cells. This can be confirmed by using a series of dyes, collectively named Christmas tree stain, to visualize immobile sperm cells. If you look on the back of the slide, you'll actually see what it looks like when they use this type of dye. However, some males do not have sperm, if they've had a vasectomy, or if they just don't have sperm present in the semen stain. Since sperm will not be present in every semen sample, forensic labs generally use PSA, prostate-specific antigen, test kits to test for the presence of seminal fluid. Seminal fluid can be confirmed if the stain reacts positively for the presence of seminal asphalt phosphatase and if prostate-specific antigen, PSA, is identified. This type of testing was used in Michella's case. The unknown DNA collected from the oral, vaginal, anal, and thigh swabs were sent to the lab to confirm the presence of semen. The Washington State Patrol Crime Lab later determined that the semen was detected on the swabs from the right thigh, vaginal, and anal swabs. Once the presence of semen was confirmed by the lab, the unknown DNA collected from the body is sent to the lab for analysis to generate a DNA profile. This process is called DNA typing. There are 4 main ways to generate a profile through DNA typing: PCR, STR, Y chromosome, and mitochondrial. STR analysis is considered the current standard for DNA typing. STR is a method of determining an individual's DNA profile by counting the number of times a small DNA sequence is repeated at a specific chromosomal location. The variable nature of STR regions that are analyzed for forensic testing intensifies the discrimination between one DNA profile and another. For example, the likelihood that any two individuals, except identical twins, will have the same 13 loci DNA profile can be as high as 1 in 1 billion or greater. Traditional DNA forensics match STRs from a sample to a known suspect or a database such as CODIS. The FBI has chosen 13 specific STR loci to serve as the standard for CODIS. Once a DNA profile has been created, it is submitted to the CODIS database to determine if the unknown sample belongs to someone who has previously been convicted of a felony. In Michella's case, the swabs collected during the autopsy were sent for analysis to generate a DNA profile in 2006. STR analysis was conducted and an unknown male DNA profile was generated. This profile was entered into CODIS, but no matches were ever found using this database. STR testing was performed again later in the investigation after investigators were able to locate a suspect through advanced DNA techniques. Michella's case grew cold, and investigators were getting desperate to get a lead in the case. Investigators decided to turn to new DNA technology to locate a suspect. In 2016, investigators sent the DNA profile to Paraben to get a snapshot profile that would predict the physical appearance of their suspect through phenotyping. In 2018, investigators permitted Paraben to upload that DNA profile to GED Match to attempt to solve the case through forensic genealogy. DNA phenotyping is the prediction of physical appearance from DNA. It can be used to generate leads in cases where there has been no suspects or database hits to narrow the suspect lists. DNA phenotyping can generate new leads about an individual even if they have not previously been identified. Paraben developed the snapshot forensic DNA phenotyping system, which accurately predicts genetic ancestry, eye color, hair color, skin color, freckling, and face shape in individuals from any ethnic background, even individuals with mixed ancestry. This technology uses deep data mining and advanced machine learning algorithms in a specialized bioinformatics pipeline. Snapshot reads tens of thousands of genetic variants, genotypes, from a DNA sample and uses this information to predict what an unknown person looks like. Forensic genealogy uses a combination of genetic and traditional genealogy to locate suspects. Genetic genealogy uses DNA technology to identify suspects by matching the unknown profile to a family member. Traditional genealogy is then used to build a family tree from publicly available websites. In Michella's case, detectives employed the snapshot DNA phenotyping to predict the physical appearance of their suspect. The snapshot analysis predicted that Michella's killer likely had fair skin, brown eyes, and brown hair, and was predominantly of Northern European ancestry. In 2018, Paraben Nano Labs uploaded the DNA data from Michella Welch's killer to GED Match, a public genetic genealogy database that permitted that type of search. Initial screening indicated that in-depth genealogy analysis could potentially provide significant information regarding the identity of the suspect. At that time, Tacoma Police approved Paraben to proceed with snapshot genetic genealogy analysis. By building the family trees of the genetic matches found in GED Match back to possible common ancestors with the suspect, and then narrowing down the possible descendants using the amount of shared DNA and the snapshot ancestry prediction, genetic genealogy identified two suspects, Gary Charles Hartman and his brother. Both lived in Tacoma, Washington during the time of the murder. Investigators placed both suspects under surveillance and eventually collected a discarded napkin from a restaurant where Gary Hartman was eating breakfast. This napkin was sent back to the lab for DNA comparison. Using traditional STR testing, the DNA from the napkin matched the DNA left at the crime scene. Hartman was arrested for the murder of Michella Welch. Hartman was later found guilty of murder after a bench trial that lasted less than 2 hours. Hartman was sentenced to 26.5 years in prison for the rape and murder of Michella Welch. Hartman then appealed his conviction, stating that he had a privacy interest in the semen that he left in Welch's body. The court rejected this argument and noted that random and suspicious list searches of abandoned DNA are prohibited, but that was not the case here. In this case, there were strong grounds to suspect that the person whose semen was found in the victim's body had killed her. Further, a warrant is not required to collect and examine DNA found at crime scenes where the DNA is used only for the purpose of identifying the suspect. All sources used during this presentation are identified on this slide.